Okay. So organic chapters, again, the same drill, something we've done for all the chapters previously. We'll be looking at introduction of, what is special about these specific functional groups. And then we'll have preparation, physical properties, chemical properties. That's it. That said, this is the biggest chapter out of all the organic chapters that you guys would have done. Aldehydes, ketones, carboxylic acids. It's not difficult. It's just, it's a lot of reactions. It's a lot of information. That's the only thing. It's just a big chapter. That's it. Some of the reactions you're already familiar with because you already done like 2 chapters of organic. So some of the reactions you already come across at hydrocarbons mein, haloalkanes mein, alcohols mein. So you'll see which ones those are. So we'll start off. We'll be doing aldehydes and ketones first. Both of them go hand in hand. They have a lot of common reactions. There are a few of them specific to aldehydes, specific to ketones also. But yeah, both of them are similar enough that we can study them together. Okay, so aldehydes, ketones, what functional groups are these? How are they defined? What do you find in them?
Aldehydes are CHO groups and ketones are CHR, COR. Right.
Just CO, yeah, just C double bond. So functionally, they are pretty much 90% the same functional group, which is C double bond. So when it is attached in the corner of the hydrocarbon chain, you get an aldehydes where the last atom is a hydrogen. When it's in the middle of the chain with carbon on both ends, what you get is a ketone. That's the only difference between both, but otherwise they both are the same in all other aspects. Okay. In terms of nomenclature, how do you name, like we're talking about IUPAC nomenclature. What is the suffix for aldehydes?
AL.
Yes, ends in AL. And ketones?
ONE.
ONE. In this, aldehydes takes the higher priority order. So aldehydes rates higher than ketones. So if you have both of these functional groups in the same compound. So for example, if you have a structure called like CH3, C double bond O, CH2, CH2, CHO. So aldehyde gets the higher priority. So this will always be carbon number 1, 2, 3, 4, 5. But how would you name the ketone? Like what would be the name of this particular compound? So 5 carbon matlab
Pentane.
4-oxopentane.
Yes. Pentane, what is the ending?
Pentanal.
Pentanal.
Or 1-al.
Yeah, pentane 1-al. Aldehydes always get Al. So if something is ending in Al, that means the position number is always 1. Okay. The double bond oxygen group. So if it is in a lower priority order, this is given like in the form of prefix. You give it the prefix oxo. Okay. So obviously you don't write it in different words. It should be the same word. So it'll be oxo and then the position number 4-oxopentanal. What if aldehyde is to be in a prefix? Or what if there's like multiple aldehydic groups and you need to indicate both of them?
Aldehyde ka prefix is formyl.
Formyl, yes, formyl. So if you have an aldehyde and a carboxylic acid takes precedence. So then the aldehydic group, call it formyl.
And then it'll be OL.
OL?
You said carboxylic acid.
So that's oic acid, no?
Sorry, sorry, not alcohol.
Yeah. And another prefix that or suffix, like another name for aldehyde that you will come across commonly is carbaldehyde. Okay, so for example, let's say we have something like this: CHO, CHO. Actually, if there's only one CHO, which is the simplest aromatic aldehyde, what is this called?
A common name is benzaldehyde and IUPAC name is benzene um, carba,
Carbaldehyde.
carbaldehyde. Yeah.
But IUPAC accepts benzaldehyde also. It's like phenol and aniline and anisole and like these sort of names. The simplest one, IUPAC accepts it. If there's two CHOs, but yeah, like Kaveri gave an example, that's kind of where you end up getting carbaldehyde. So this will be benzene, because there's a benzene ring, and two CHO groups specifically, benzene dicarbaldehyde. Actually, it'll be 1, 2 benzene dicarbaldehyde to show their position numbers also. So yeah, so when it's in the form of a prefix, you use formyl, and other situations when like aldehyde is the functional group, but it's like in the middle of a chain or something like that, you can end up using carbaldehyde. Like when you cannot end the name in AL, then you can use carbaldehyde. Okay. All right. Then special thing again, in both aldehydes and ketones, they are defined by the C double bond O. Just that depending on where the position is, differs between aldehyde and ketone. So, what is the hybridization of carbon in this functional group?
sp2.
Correct. So this is hybridization. It has one pi bond with oxygen, the oxygen atom. And what would be the shape, the geometry? Yes. What shape?
Trigonal planar.
Trigonal planar, yes. This bond is also polarized. So oxygen being electronegative, this would have a slight negative charge. This has a positive charge. So this is important because a lot of reactions are defined by this sort of a polarity. So if it's a reaction with electrophiles, then you know which atom it's going to attack. If there's like a nucleophile, you know which atom is going to attack. Okay. So this is polarized. The CO bond is polarized, not this bond. We're talking about this particular part. So yeah, so this will come back to it when we're doing the chemical properties. Polarization plays an important part then. So we'll start first section, preparation. First method of preparation, we look at oxidation. Like oxidation may be different ways of oxidizing. But this reaction is something that you guys know very well. So what do you oxidize in order to get aldehydes or ketones? किसको ऑक्सीडाइज करने पे you'll get aldehydes ketones?
Alcohol.
Yes. Now specifics, if I want to get aldehydes, what do I need to oxidize?
Primary alcohols.
Yes, primary alcohols, which is end of the chain, will give me aldehydes. And for ketones,
Secondary alcohol.
secondary alcohols. Okay. So, reagents that you can use, oxidizing agent.
PC, no. Sorry, but what was PCC, like unrelated? What was that?
PCC also you can use. Yeah, PCC.
LiHH, or is that something else?
LiAlH4 has hydrogen. Will you be able to oxidize that?
That is reduction.
Can,
Oh, yeah,
when
that
can
is reduction.
CrO3.
CrO3, yes, PCC is one, CrO3. So you can look at oxidation of alcohol
KMNO4.
things. Yes, KMNO4, but it needs to be like
what is strong?
dilute KMNO4.
When we say acidic KMNO4, why is that?
Because that strength is higher, like it's going to oxidize it and it's going to oxidize it to an acid. But we want, this is preparation of aldehydes and ketones we're talking about, no? So make it dilute, reduce its strength. KMNO4 or K2Cr2O7, dichromate permanganate, etc. So this is, you can look back in the oxidation of alcohol section. So that's one way of preparing it. Okay, so finish noting, then we look at the other thing. The first three methods are going to be reactions that you've already studied, at least like two of them. This one might be new. Yeah.
What was full form of PCC?
Pyridinium chlorochromate.
When we use that, is this KMNO4 different, like the conditions of this KMNO4, are they different from when we use it to convert ketones to carboxylic acids?
Yeah, like you, yeah, I mean, there's no standard that you just like take it from a bottle and use the reagent. You need to prepare it in advance. And how you prepare it, like what concentration you're going to take it at, what temperature you're going to take it at, is going to depend on the reaction that you're doing. It'll also depend on how much quantity of the uh, reagent, the reactant that you are taking. It depends on all those factors. Another thing, so whenever you're using specifically like potassium permanganate, potassium dichromate, these are mainly used in laboratory conditions. You will never use these in industrial preparation methods. So for industrial oxidation, you'll have to like heated copper tubes, like passing these vapors through heated copper tubes. There's like other methods that you'd use in the industrial thing. The scale of these things is small. Okay. This next one is also technically coming under oxidation, but it's not addition of oxygen. We're looking at dehydrogenation. So dehydrogenation of alcohols. So this method, this is an industrial method of preparation, and you use volatile alcohols. So basically, you use this method to prepare the smaller aldehydes. You want the alcohols to be volatile, to be easily vaporized. So that's the point of mentioning volatile alcohols. Yeah. So dehydrogenation of alcohols. So alcohols, you have ROH. So ROH in vapor form. You pass them through silver or copper, heated silver or copper tubes. So in the presence of silver or copper, it's vapor, so you're like heating it a fair bit. Dehydrogenation, so there's hydrogen lost from the carbon that's attached here. This hydrogen attached to oxygen is lost, and what you end up with would be an aldehyde if you're using a primary alcohol, or a ketone if you're using secondary. We'll do a couple of examples. So suppose I have CH3, CH2, OH. So when we pass through, like in the presence of copper or silver, so there's a hydrogen from here, and one of the hydrogens attached to the carbon is lost, and what you end up getting would be CH3, C double bond OH. It's like similar to dehydrogenation of alkanes in order to get alkenes, similar to that, except you're losing it from an alcohol. So one hydrogen from here, one hydrogen from here lost. So this ends up becoming a double bond. And if you're working with secondary alcohol, say isopropyl alcohol, so this hydrogen will be lost in the presence of Ag or Cu. You lose the hydrogen and you end up getting a ketone, C double bond O, CH3. Okay. So dehydrogenation of alcohols, another method.
Why vapor?
This one takes place at a higher temperature, and you want the molecules to be in gaseous form. So when you pass these vapors, alcohol vapors, in the presence of silver or copper, copper is mainly used, but can take place with silver also. So end up getting aldehydes and ketones. It's like a catalytic dehydrogenation. ठीक है?
1 second.
हाँ.
In the iso wala example,
So this is a primary alcohol. This is a secondary alcohol. So primary, say you get aldehyde purely because it's at the end of the chain. And secondary, say you get ketone, again, purely only because it's in the middle of the chain. So wherever the oxygen is, that's where you get a double bond. So that decides whether you get aldehyde or ketone.
I understand purely because it's at the end, purely because it's at the middle. Why?
Because wherever oxygen is, that's where you end up getting the double bond, right? So when the hydrogens are lost, it's at the end of the chain. Because it's on the end, you end up getting an aldehyde. If it's in the middle, that's a secondary alcohol, end up getting a ketone. Okay. Then, third method, I don't know if you guys remember it. Do you remember ozonolysis of alkenes? This is a characteristic, this is a reaction of alkenes. The alkynes will take place, but mainly alkenes is used. And so you, for this, if you want a specific aldehyde or a ketone, you need to choose the alkene based on that. Because the reaction will always, like the mechanism will always take place in the same way. Do you remember it? So any alkene, you have a double bond.
We do it, and then the house thing it becomes
Yes.
like that. It
Yes.
separates.
Correct. The second step, you end up like this is the addition of ozone. Ozonolysis, so the double bond breaks. That's the lysis part of it. Then what is the reagent that you use in order to break this apart?
ZNO.
Sudden.
Hydrolysis with zinc. So zinc and H2O, zinc and water. So this will end up, so you end up getting, like, it's the same. Suppose we have XY over here. Same thing, same X and same Y. This, you'll have a double bond O. And then same thing on the other side also. X, Y, double bond O. So if you want a mixture of a specific aldehyde or a ketone, then you select that particular aldehyde that has those particular atoms on the each side of the double bond. If you want the same aldehyde, like, so for example, if I want to prepare only acetaldehyde, what alkene should I start with in this reaction? Reverse engineer it. What is the structure for acetaldehyde?
Butene. Butene.
Huh? No, butene is right, but like be more specific. Where should you put where should the double bond be?
Butene. Yeah, I said
Butene, acha.
yeah.
Sorry, I heard something else. Sorry. Yeah. Butene, correct. So CH3CHO chahiye na. We want only acetaldehyde. So both the like aldehyde or ketone that is produced should be the same molecule. So end may we want C double bond O H CH3 and same thing C double bond O H CH3. So the aldehyde that I start off with, so in place of the double bond O, both the carbon atoms are connected to each other. So this is what I need to start off with. If you see this, 4 carbon atom, but, second place में double bond, so butene. Yeah, carbon.
Is the simplest aldehyde acetaldehyde or formaldehyde?
Formaldehyde is the simplest one.
But then how? It's only HCHO, so उसमें R तो है ही नहीं ना. So
R is a hydrogen atom. So basically, CH2 is the aldehydic group now. So single bond can be fulfilled by anything. And aldehydes like if it's not substituted, we define it as atoms containing only carbon and hydrogen along with CHO group. So on that basis, we already
Always write R while writing the general formula. Why?
can be H, and then this is the simplest aldehyde with one carbon atom. And then when you
Yeah.
want to increase the number of carbon atoms, then you put another carbon. To fulfill the valency, this becomes CH3. And then one more becomes CH2, CH3. So that's how it increases. So let's complete this reaction. Presence of ozone. Get H, CH3.
I didn't understand how you can figure out by looking at the aldehyde which alkene you're supposed to use for ozonolysis.
Huh. So ignore all of this. Like keep things simple. What is essentially happening is, like, if you just want to get the hang of this reaction, so wherever the double bond is there, so this double bond is breaking, and in place of the double bond, you're getting double bond O. That's the point of this reaction. Okay, so if we want preparation of a specific thing, like, okay, next example, let's take preparation of acetone. So acetone ka structure is CH3, C double bond O, CH3. If we want only acetone and nothing else, well, both the molecules that are produced here should be acetone, right? So my end product should look like this: CH3, C double bond O, CH3, and same thing, CH3, C double bond O, CH3. So based on this reaction, जहाँ पे भी double bond O आ रहा है, that started off as the double bond of the alkene, right? Yeah.
What?
See, the double bond of the alkene is breaking, and in the place of the double bond, I'm getting the oxygen atoms.
Yeah, right. Yeah.
So उसका उल्टा चाहिए हमें. So wherever the oxygens are there, उसके place में I want the double bond. So wherever the oxygens are there, उसके place में they should be connected by a double bond. And the rest of it remains the same. Let's see, okay, what molecule is this? Then you'll get the name of this. Yeah.
Understood.
Cool. Complete this reaction, guys. Like example 2, let's say, preparation of acetone. So
Can you go back? Sorry.
So note down the reactions. So we have one example, acetaldehyde. Also note down the example for acetone also. So once you're done writing both, let me know. And Send the answer on chat. What do you get on ozonolysis
Yes,
of?
I was writing the previous one also.
Oh, still not done. Okay. So let's call it XY and AB. On this side, if we have A and B, the same A, like A and B will remain as it is. So C double bond O, AB.
The only difference between how we do ozonolysis for ketones and aldehydes is the H will be CH3, right? Or some other R group, whatever. Like the open
Like
H.
you just have to choose, like this double bonded carbon will be attached to two other groups, right? So you
Yeah.
just have to choose what groups are attached here. So based on that, you'll get that particular aldehyde or ketone.
Yeah.
Okay. So tell me, what do you get on ozonolysis? Finish this reaction also, okay, for acetone, the reagent and everything. After this, figure out what do you get on ozonolysis of propene. So propene is CH3, CH double bond CH2. इसके ozonolysis पे what do you get from this reaction? So O3 and also like give me the end products.
Ma'am,
Step O3, yeah.
we're not always supposed to get the same, like Joe, for example, for acetone, we got acetone plus acetone, right? So it's not always necessary because this is not symmetrical. So it's not always necessary that we'll get like that, no?
Absolutely, yeah. So you'll have to see what is there on both the sides to be able
So
to.
basically, one of the products has to be the aldehyde or ketone. Doesn't have to be both.
Again, it depends. You might get only ketone, like because I took a symmetrical this thing, I got the same ketone on like as the end product. If it's not symmetrical, then depending on you might get two different aldehydes or an aldehyde or and a ketone or two different ketones. So it all depends on what you have on both sides of the double bond. Smera and Sia have gotten yes. That's it. When you're writing in the books, practice the intermediate that you get also. Kaveri, is that the only one? Yes, Kaveri and Arya, both of you got it. So in place of double bond, just put an oxygen, see what you get. That's it. You get CH3, CH double bond O. So it's basically CH3CHO. And CH2 and double bond O, which is HCHO. So ethanol plus methanol, acetaldehyde, formaldehyde. Yeah. Okay. We are still noting, not done with this yet. Yeah. No?
Done.